I'm supposed to. Okay. Hello, everyone. Good evening. Thank you for being here for the Science on the Sound series at the Coastal Studies Institute. This is a monthly program open to the public to try and bring science to our community. So thanks for joining us for the December edition. Typically, we announce the following month's presentation. I don't have that information for you right now, but please stay tuned or look for an announcement coming soon. So tonight's Science on the Sound is highlighting the Capstone Research presentation of the Outer Banks Field Site class of 2023. My name is Lindsay Dubbs, and I am the director of the Outer Banks Field Site, and I teach the ecology course for the site, and along with my colleague, Dr. Linda Dana, we mentor the students through this Capstone Research Project. And I'm gonna turn the mic over to the students in just a minute, but before I do, I just wanted to provide a little bit of context for the research you're about to see and hear about, and to express thanks to the people and entities that helped to get the students to this point. So we have enjoyed working with and getting to know this group of students. Their strengths have really melded together beautifully to create an impressive team. And we are very proud of you as a group and individuals. And I hope that you all enjoy this short time that you have with the students this evening. And I hope that you're as impressed as you are with what they've accomplished, keeping in mind that the research that you're going to hear about today is not the only thing that they've been doing here. They took 3 classes, a seminar, and a lab, and they also participated in an internship project with either a research group or a local entity. The students will mention those projects when they introduce themselves in just a minute, but if you'd like to learn more about what they did, please join us after the presentation for a reception in the 2nd and 3rd floor atriums. We also would like you to keep in mind that the capstone is first and foremost an educational experience for our students. It's an opportunity for them to apply what they've learned from their tenure at UNC-Chapel Hill, our field site, and life to a real-world issue of importance to the Outer Banks. So a lot of research projects last between 1 year to 5 years, and sometimes longer. And they just had 4 months to complete this project. And we wish that we could keep them here longer to continue the work, but all of them will be off to other pursuits at the end of this week. So that is kind of providing the context, and now for the thanks. Please bear with me. As I said, there are a lot of people and entities who make the Outer Banks Field Site possible, including our host institution, the Coastal Studies Institute on the Outer Banks East Carolina University campus. Director Corbett and the faculty and staff of CSI provide a beautiful, welcoming space and an enriching environment. And one of the people that is really helpful, especially tonight, is John McCord. John, thanks for recording and live streaming for us today and for allowing us to be the spotlight of Science on the Sound. At Chapel Hill, the Study Abroad Office, the Institute for the Environment, and the Environment, Ecology, and Energy program provide our fundamental academic and operational structure, and the people who support everything from accounting to emergency management to curriculum. And we appreciate all of that. This year, the students and faculty were very lucky to be assisted by a resident advisor, Rebecca Lidauer, and Rebecca was also our, is an alumni of the field site, so that's really fun to have her here with the students, so thank you, Rebecca. The success of the Capstone Research Project specifically benefited from inspiration of one of our CAB members, or Community Advisory Board members, Rana Paris, who suggested the topic. Thanks, Rana. We also appreciate the satellite imagery analysis expertise lent by Dr. Stu Hamilton, our colleague here at CSI, and the Network for Endangered Sea Turtles and their president, Tony Parisi, and the National Park Service for sharing their turtle nesting data with us. Last but not least, we greatly appreciate the community members who took the time to complete the survey for this project and the businesses and organizations that allowed the students to intercept participants on their properties. There were community members who offered the students experience and insights they would not have otherwise had during field trips and guest lectures. So thank you to all of those folks as well. Special thanks to our Community Advisory Board for your mentorship and support of the students throughout the semester. Thanks to the internship mentors for sharing your time and expertise with the students as you allowed them to gain some real-world experience in the environmental research and law professions. And finally, I know you're probably very happy I'm saying finally, I would like to recognize the committed faculty who I and the students are lucky to learn from and interact with over the course of the semester. Dr. Andy Keeler teaches environmental economics and policy for the site, and Dr. Linda Dana is the coastal management professor. This year, we also had several lawyers who contributed to our curriculum, including an alumnus, Danielle Curtis, lawyers that live locally, Lee Leidy and John Everett, as well as those that live kind of near and far, Mary Carson Stiff and Zach Barr. Okay, I promise that I'm almost done. There are just a few things that I ask of you. Please silence your cell phones. Also, everyone, we look forward to your comments and questions and points of discussion at the end of the presentation, but please hold off until the end of the presentation. And again, please join us afterward for a reception in the second and third floor atriums. Finally, if you'd like to hear any more about our program, you can simply type in OBXFS into any search engine and you will find us. So thank you again for being here, for your interest and support, and please join me in welcoming the Outer Banks Field Site Class of 2023. Oh, yeah.
Hello, my name is Abigail Montes de Oca. I'm a sophomore from Winston-Salem, North Carolina, and my internship this semester was with the North Carolina Aquarium.
Hi, I'm Elise Benware. I'm a junior. I'm from Durham, North Carolina, and my internship was with Wetlands Watch.
Hello, I'm Ashlyn Bassnight. I'm a senior from Youngsville, North Carolina, and this semester I interned with the town of Duck.
Hi, I'm Nikki Corsi. I am a sophomore, and I'm from Topsail, North Carolina, and I intern with the Atlantic Marine Energy Center.
Hi, my name is Chloe Williamson. I'm a junior from Durham, North Carolina, and this semester I interned with the North Carolina Coastal Federation.
Hi, my name is Kenza Hassini. I'm a junior from Chapel Hill, and this semester I interned with the National Park Service.
Hello, my name is Sarah Montague. I'm a senior from Charlotte, North Carolina, and this semester I interned with the Nature Conservancy.
Hi, I'm Laura Flynn. I'm a senior from Charlotte, North Carolina, and this semester I internshipped with Quibel and Associates.
Hello, I'm Eleanor Hennessy. I'm from Pittsboro, North Carolina. I'm a sophomore, and I interned with the Morley Fishery and Ecology Lab here at CSI.
Hi, I'm Naja Pope. I'm a junior from Washington, North Carolina, and this semester I interned with CSI's Education and Outreach Department.
Hey everybody, my name is Drew Huffman. I'm a senior from Hickory, North Carolina, and my internship this semester was with the North Carolina Coastal Reserve.
Hello, everybody. My name is Julie Yakuboski. I'm a junior from Apex, North Carolina, and I interned with the Nature Conservancy this semester. Hello, thank you and welcome, and thank you for coming to our presentation. We're very excited that you're here to join us tonight. As Lindsay already mentioned, we're students at UNC and we're studying here this semester doing a research project. As you can see, our research topic was artificial light at night, public perception, sea turtle nesting, and spatio-temporal change in North Carolina's Outer Banks. Before we begin, I would like to take a second to point out that throughout this presentation, we will be referring to artificial light at night by the acronym ALAN. Saying artificial light at night is kind of a mouthful, but if at any point you get confused and don't remember what ALAN stands for, feel free to raise your hand and let us know, and we'd be happy to repeat ourselves. So, what is ALAN? Well, first of all, ALAN is any form of light at night that is not caused by the natural environment. So, for example, moonlight would not be considered a form of ALAN, but street lamps would be. As you can see through the picture, ALAN can come in several different forms. There could be light trespass, where light is cast where it's not needed or wanted. Glare, where light is too strong and your eyes are not accustomed to it and it causes visual impairment. Light clutter, where there's excessive grouping of lights. And sky glow, where the light is cast upward and blocks out the sky. So why do we care about ALAN? Well, ALAN is an increasing problem, and it's growing with increases in both technology and development. And the more studies that are done, the more we're learning about its negative effects. For example, ALAN has negative effects on ecology, health, energy consumption and greenhouse gas emissions, and the night sky. As you can see in this picture right here, on the far left, you have a night sky with ALAN. You can't see any stars, you can't see the Milky Way, it just looks blue. Whereas on the far right, you have a sky without ALAN. You can see plenty of stars, you can see the Milky Way, it looks completely different. Now, if ALAN is such a problem, then why do we have it? Why is it increasing? Well, it's important to note that ALAN does have many benefits. For example, people tend to feel safer with light at night. People need headlights on their car to see the road, and it allows us to extend the activities we perform in the daylight throughout the nighttime. If we didn't have ALAN, people would probably just be forced to go to bed. Now, I will pass it off to Drew, who's going to be talking about the state of knowledge on coastal ALAN.
Yeah, thank you so much, Julie. Now I'd like to touch a little bit on the existing literature and the current knowledge about ALAN. We know that this is a global issue. It's taking place all over the world, as you can see in this figure on the right side. The top half of the figure represents the global mean artificial light at night from the years 1993 to 2012. So you can see there's a high concentration of light in the eastern United States, Europe, and across Asia. The bottom portion of this figure demonstrates the change in the amount of artificial light at night across the world, with the blue coloration indicating a decrease and the yellow indicating an increase. So you can see there's more of an increase across Europe and Asia, and then you see more of a decrease in the northeastern part of North America. We also know that 22% of global coastlines are being affected by ALAN, so that's quite a big number. We know that ALAN affects wildlife. Specifically here on the Outer Banks, we know that ALAN can affect sea turtles in the way that they move from their nest when they first hatch into the ocean. They can get easily disoriented by lights along the street, by car headlights, or also lights on buildings. We know that ALAN is also perceived very differently among different groups of people. We know that age and population density, and also where you live, such as an urban area or a more rural area, can affect the way that you perceive ALAN. So it's very important that we try and look into that and understand what it's like here on the Outer Banks and how people are perceiving it differently. And there's also there's a scarcity of existing literature on artificial light at night in coastal systems as opposed to what we know about more terrestrial systems. So that's part of another aim of our research, is to try and expand upon that knowledge so that we have kind of a grasp of what things are like for coastal systems and artificial light at night. Our study is going to be a natural science component and a social science component. The natural science will be looking at the change in artificial light at night across this region over the last 9 years, and also how it's affecting sea turtle nesting habits. And we're also going to be looking into the way that the public perceives ALAN here in this region. And our study site goes all the way up from Currituck County down to Nags Head, and also includes Manio and Wanchese for the survey data. I'd now like to introduce Nigel Pope to talk a little bit about the natural science methods of our research.
Thank you, Drew. So now we're going to get into the methodology and the results of the natural science portion of our research. So the first research question that natural science addressed was how Allen has changed both spatially and temporally throughout the Outer Banks over the last 9 years. So the first method that natural science used to collect their data was satellite. And for our satellite measurements, we use VIRS, which stands for Visible Infrared Imaging Radiometer Suite. And what VIRS does is it observes and collects satellite measurements of visible and infrared wavelength spectrums on a global setting. So generally speaking, VIRS is measuring the radiance of light, both visible and infrared, on land, ocean, as well as in the atmosphere. And in this animation right here to the right, we can see the satellites SWOMI NPP and NOAA 20 doing an orbital path around the globe as they collect the electromagnetic radiation that is seen through the visible light. Just to give a visual of how the satellite-based Allen measurements are being collected. So for our VIRS data set, we used these grid locations which were provided to us by Stu Hamilton, which, as Lindsay said, was a faculty member here at CSI. And these grid locations range from our southernmost point, which was Oregon Inlet, all the way up to our northernmost point, which was in Currituck County, close to the Virginia border. And to represent those grid locations, we use letters, starting at our southernmost point, which was letter A, all the way up to our northernmost point, which was V. And these grid locations are about 4 kilometers apart in distance, aside from our southernmost point in Oregon Inlet, which was about half that distance, just so we didn't have it span over the inlet and the water that it encompasses. And these grid locations are an accumulation of a monthly average of satellite data that was collected from 2014 all the way to 2022. And now I'm going to pass it over to Ella, who's going to talk more about our first research question.
Hey guys. So we also wanted to look at conservation areas along our study site. So all of the purple is the managed land areas, and you can see at the top or at the north and south we have there's more managed land areas than in the middle, and I gotta remember how to use this. And so in the north there's managed land areas such as the Currituck National Wildlife Refuge, and in the south we have the conserved seashore. And so and then we're gonna take out. Oh, sorry, I'm freaking out, guys. So we're gonna take out grids H and A. H because it's in Kill Devil Hills near First Street, if you guys know where that is. And there's not a ton of conserved area around there. Whereas in A, that's near Oregon Inlet, and there's a lot more conserved area. So if we go to the next chart, so site H again, Kill Devil Hills, a lot more activity happened up there. Their baseline Allen level or radiance in the big long unit is already a lot higher than that in Oregon Inlet. And so all of our 21 satellite grids followed one of these patterns. These two were just the easiest to take out so you guys weren't looking at a big mess. And so all of them followed this pattern, with those that had less conserved area in them having a higher baseline, and then they all had that sharper peak in the summer season, which we think is due to tourist activity. And then all of those that had more conserved areas, such as near Oregon Inlet, they still had a small peak in the summer months. It was much smaller than that in those places with less conserved area. And so now we're going to be talking about percent change. And so to orient you guys, on the left y-axis we have our percent change of each area, and then on the x-axis we have all of our 21 sites going from south to north. And then on our right y-axis we have our satellite-based Allen measurements. So the blue columns are the percent change, and the orange line is the Allen measurement. So where you can see that Allen is really high, and again, here is First Street, Kill Devil Hills, there is a lot less percent change within the last 9 years. And we think that this is due to all of these areas becoming really highly developed before 2014. And now Abigail's going to talk to, or no, not Abigail, Laura's going to talk to us about our second research question.
Thank you, Ella. So for our second research question, we looked at, do satellite measurements of artificial light at night align with on-the-ground measurements of artificial light at night? So Nija already introduced us to our first method that we use to gather Allen. Our second method is one that we got to actually go out and take ourselves, and we referred to it as our on-the-ground method. We went to 14 separate beach access points with our little sky quality meter, and we would go on new moon nights, and we would hold it up. We'd take 4 quick measurements in each direction, and then we would average it together to get the average luminance from the ground up. So the sky quality meter itself is a measure of night sky brightness, and the values are inversely related to darkness. So the higher number you got actually meant that there was less Allen and it was darker outside, so you could see the night sky and the stars better. So our on-the-ground measurement locations, we tried to get them to align with our satellite data points as best that we could. Our northernmost point being Corolla, and our southernmost point being Oregon Inlet. However, you can see there was quite a gap between Barrier Island and Corolla. This was due to the lack of public beach access and public parking within those areas. We also could not go above Corolla because none of our cars could go off-roading in the sand. So to look at September through November 2022 satellite-based Allen versus our 2023 on-the-ground Allen measurements, we plotted them again from south to north. And on-the-ground measurements for each sampling location and satellite-based Allen show the same trend. So if you start in the southern, there's the least amount of Allen. As we go towards the middle of our sampling location, there was more. And then as you go back down towards the northern points, there was less again. So now I'm going to introduce Sarah to come up and finish out research question 2.
Thank you, Laura. All right, so this first map shows our on-ground average measurements that we took over the course of the semester. You will see that there are some grids that do not have values in them, and that is because, like Laura said, we were unable to take on-ground measurements in all of those areas. This second map is showing the satellite average radiance from 2014 to 2022 over the course of that whole time. So you'll see that the patterns of light and dark are very similar on these two maps. While we only have one sampling location for our on-ground measurements, you will still notice that in both of the northern areas of the maps, it is much darker in those areas, and this pattern is also seen in the southernmost part of the map. Also centered around our H grid, which is in Kill Devil Hills, you'll notice that this is the brightest area in both of our types of data collection. Moving on to our next natural science research question. Is there a relationship between sea turtle nesting and artificial light at night across the Outer Banks over the last 9 years? And if so, what is it? So we went about answering this research question by getting data from the Network for Endangered Sea Turtles and the National Park Service. We had locations of every sea turtle nest in our study site ranging from 2014 to 2022, as well as data of the locations of all of the false crawls. A false crawl is when a sea turtle, for some reason, crawls onto the beach and does not lay a nest, which is abnormal because normally the only reason a sea turtle would crawl onto the beach is either to lay a nest or if it was very sick. So we compared turtle data to our satellite data set to find any trends between turtle activity and light. And now I'm going to introduce Kinza, who is going to explain the analysis that we did.
Okay, so the first thing we looked at when it came to turtle activity was how it's changed over the years of our study. So the years of our study, again, are 2014 to 2020. And when I'm talking about turtle activity, I'm talking about the combination of both nests and false crawls. And so we saw an overall increase in turtle activity among these years, with some significant change and significant differences between years. For example, 2016 has over 100 nests, while the following year, 2017, has about 30 or 40 nests. And one of the reasons that we think there might be this increase overall is because of conservation efforts, both things like the Endangered Species Act that have protected a lot of these species, and also management efforts by organizations like NEST and the National Park Service have perhaps helped increase the number of turtles that we're seeing along the coast. The next thing we wanted to look at is how latitude is correlated, or if it is correlated, with nests and false crawls separately. So we found that there is a correlation between nesting and latitude, and this can be seen in the map on the left. The darker the green means that there are more nests. So as you can see, when you go down the coast, down to Oregon Inlet, the darker the green becomes, showing there's more nests as you go south. And this makes sense because North Carolina is one of the northernmost points for turtle nesting, and so turtles just naturally are going to nest more in the southern areas because it's a better habitat for them, the water is warmer, and that's where they're going to nest naturally. However, when you look at the pattern for false crawls, we aren't seeing the same pattern. We don't find any significant correlation between false crawls and latitude. In fact, we're seeing more false crawls in the north here, and then more again in the south, and kind of less in the middle range. And when we compare this to our satellite-based Allen map, we can kind of see that there seems to be a correlation between our darkest areas in the north here, and in the south, and then our areas with the most false crawls in the north again, and in the south again. We don't know exactly why this might be, but we do know that statistically there is a correlation between satellite-based Allen and where false crawls happen. There are a lot of variables that come into play with false crawls, so we don't know exactly why we're seeing this trend. To show this trend again, but in graph form, this graph shows, again, the locations of our study from Oregon Inlet going north to Corolla. And then on the y-axis to the left here, we have radians, so our satellite-based Allen measurements. And then on the y-axis to the right here, we have our number of false crawls. So we see in the blue boxes a decrease in false crawls as you go north, and then an increase again all the way up to Corolla. And then we see kind of this opposite trend with the orange line, which is our island data, and we see an increase going to the middle and then a decrease again in the north. And when we look at the same graph, but with our nesting data, we don't see the same pattern. We see this significant correlation with latitude. So as you go south to north, we see a decrease in nesting. And then we see again this orange light, which is our satellite data increasing, and we don't see this correlation like we do with false crawls. And we think of why we're maybe seeing these trends along the Outer Banks here. Our first theory is that perhaps there's a certain threshold that needs to be met. Maybe as darkness continues to disappear along the coast, there's going to be a certain level that turtles aren't able to tolerate. So they're going to be deterred from nesting in certain areas as darkness continues to disappear. The second theory is that perhaps our latitude influence here is just greater than the influence of artificial light at night. Because we are one of the northernmost areas, maybe turtles choose to nest mainly based off latitude and not so much on artificial light. Our last theory is that perhaps our sample size is too small. Different places like Florida, where they have done similar studies, they have shown a significant correlation between nesting and light. They have a lot bigger of a sample size. They have tens of thousands of nests there per year. We have, in our study range, maybe 100 per year. So maybe our study sample is just too small to show this behavior. Okay, that's a wrap on our natural science results. I'm going to pass it on to Chloe, who's going to introduce our methods for social science.
Thank you, Kenza. So now that we looked at artificial light at night, how it's changed over time, and its effect on creatures like sea turtles, we also wanted to take a look at how does Allen affect the community in the Outer Banks? How does it affect people in our society? So our first research question on the social side is, what are the local, resident, and visitor attitudes and views of Allen on the Outer Banks? I'd like to bring Nikki up here to talk some more about the survey that we conducted.
Thank you, Chloe. So, like Chloe mentioned, we created a survey and we distributed it to probably some of you in the crowd right now, but a large part of the Outer Banks community. This survey had about 28 questions with 5 categories. These categories were knowledge, which some questions were like, what is Allen? Just trying to see like what did people already know about Allen on the Outer Banks? What is their perception? For example, a question was like, what light sources do you view as disruptive at night? What is their experience with Allen? What is their willingness to change? For example, would people be willing to put dimmer switches up on their house lights, or would there be a certain time at night that people would be willing to turn off their lights? And then we also got some demographic statistics as well. What was the gender, the education level of our respondents, and then our distribution methods for our survey included, we got it in the Outer Banks Voice, the newspaper here on the Outer Banks. We were also able to get it in the Nag's Head and Duck newsletters as well, which really helped us get a lot more participants from those areas. And then we also did quite a bit of interception work. So you might have seen us at the farmer's market. Maybe we were at Front Porch. We went to grocery stores. We tried to go to a lot of different locations to make sure that we were getting a large sample size and a representative sample of the Outer Banks community. So like I mentioned, our study site is from Corolla to Wanchese. So then we looked at what was the demographics like of our survey? How many were we able to collect? So our goal was to get 500 respondents. We did end up meeting that goal with 512. However, we did have to remove some of those respondents because they were outside of our study range or they did not meet the 50% threshold that we needed them to complete of the survey. We did find that 65% of our survey was female, so that's just an interesting finding. We also noted that a large percentage of our respondents were in the 40 to 79 age bracket. We also found that 71% of our respondents had a 4-year college, graduate, or professional degree. And then when we were looking and breaking down these numbers even further, we saw that 70% of our respondents were year-round residents, while only 11% were visitors. Now I'm going to bring up Ashlyn, and she's going to talk to us more about the results of our survey.
All right, so like Nikki was saying, the knowledge portion of our survey was really important to understand what people know about Allen here in the Outer Banks. First, we wanted to know what people actually think they know about Allen, though. To do this, we asked them, how informed do you feel you are about artificial light at night and its impacts? And we gave them 5 different answer choices. These were not at all, very little, somewhat, moderately, and very well. And you can see these represented on this x-axis right here. And then on the y-axis, you can see the percentage of respondents. You can see that the highest number of respondents identified with the somewhat option. Next, we wanted to figure out how much they actually know about Allen. To do this, we used questions about the forms of light pollution, as well as the different effects of cool light tones versus warm light tones. And we also want to know what they knew about various effects of Allen, including those on the night sky, health impacts, and those on sea turtles. We used multiple choice questions, true or false questions, and select all that apply questions. And when we were assessing these, we totaled up the points to a total of 9. And you can see from our figure here that luckily no one got a score of 0, which is good. So that put our range at 1 through 9, and most people got a score of 6 out of 9. All right, and then we want to see if there's any possible connection between what people think they know about Allen and what they actually know. And this is a more complicated figure, but I'll break it down a little more. We have these same categories of the self-assessed knowledge here on the x-axis. And then on this y-axis here, we have the amount of respondents that identified with those options. But these numbers here are where we calculate the averages for each of these categories to find their average knowledge score. For example, if people identified most with the none at all category, on average they got 5.16 points out of 9 on the knowledge portion. And you can see, due to this positive increasing trend, that it looks like people have a pretty good idea of how much knowledge they have. But if we recall, these points are only out of 9. Our lowest score is 5.16 on average, and the highest score is 6.49. That's only about a point. This means that people have relatively the same amount of knowledge on Allen here, even if they rate themselves very differently, from none at all to very well. All right, and now Julie's going to talk some more about our social science results.
Thank you, Ashlyn. So, as Chloe previously mentioned, just like natural science, social science also had research questions. And our first research question had to deal with people's attitudes and beliefs of Allen. To answer this research question, we had our survey. And specifically, we had a question asking people about their overall opinion of Allen in the Outer Banks. As you can see on this graph, they had 5 answer choices they could choose from. They could have chosen, I'm not concerned about it at all, I'm slightly concerned about it, I'm not sure, I'm concerned about it, and I'm very concerned about it. As you can see from the graph, the majority of people chose either I'm very concerned about it or I'm concerned about it. Taking these two together, that's about 70% of our responses. And what's interesting about this graph is that if you look at it, you can see that to at least some degree, most people are concerned about Allen. We have very few people who chose I'm not concerned about it at all. Then, after we had our results for this question, we were interested in seeing if demographic variables influenced how people were responding. So the demographic factors that we looked at are listed here: residence, town, gender, and age. You can see here that 3 of them are bolded. This is because that we found significant relationships with these 3 demographic variables, meaning that these 3 things, residence, town, and gender, did influence how people were choosing. For example, let's take residence. Residence was broken down into visitors, seasonal residents, and year-round residents. And we found that year-round residents were more likely to choose higher levels of concern. After that, we asked a question about people's perceived effects of Allen. Again, this was to address our research question of people's attitudes and beliefs about Allen. So for this question, we had a list of categories. You can see here it goes from stargazing all the way to down to human health. In this question, people were asked to respond with what kind of effect they thought Allen was having on these different categories. So they could have chosen highly negatively, which is this dark red, negatively, which is this lighter red, has no effect, which is the yellow, positively, which is light green, highly positively, which is this dark green, and unsure, don't know, which is the gray. If you look at this graph, you notice that you're seeing a lot of red. This means that overall, people think that Allen has a negative impact on all of these different categories. Let's look at sea turtles in particular. If you look at sea turtles, you can see that most people chose the highly negatively category. There's a ton of dark red. And what's interesting about this graph as well is that just like levels of concern, again, we looked at demographic variables and if they were having an influence on people's answer choices. Using the example of sea turtles again, we looked at residency, town, gender, and age, and as you'll notice, they're all bolded. So all of these variables had an impact on how people responded, on what kind of effect people thought that Allen had on sea turtles. Again, using residency, we found that full-time residents had higher levels of concern for Allen's effect on sea turtles, or they thought it had a highly negative effect on sea turtles. One more interesting thing about this graph is that you'll notice that there is a section of green. And you can see here that this has to do with the category of personal safety, showing that people do tend to feel safer with Allen. Now I will turn it over to Chloe to talk about the necessity of light sources.
Thank you, Julie. So when looking at this category, we wanted to know, how does light source and Allen affect people in their everyday lives, and how do they view it as affecting them directly as opposed to their knowledge on other topics? So we asked yes or no question, do you believe that this type of Allen is necessary? So for these categories, we chose exterior residential, so the lights outside of houses, public buildings, street light, and parking lots. And we can see from this graph that the most respondents believed that parking lot light was necessary, and while the least amount of respondents believed that public building light was necessary. We then took this necessary data and combined it with other data that we had about the level of disruption. So we also asked respondents, how disruptive do you find this certain source of light? And we had the categories as excessively, which is represented by the dark red, moderately, which is represented by this pink, slightly, which is represented by the orange, and not at all, which is represented by the yellow. And what we can take away from this graph is that the more disrupted people feel by a certain source of light, the less they're likely to think that it's necessary. So for example, we can take a look at exterior residential, and we can see that the people that answered, yes, I do think that exterior residential light is necessary, were far less likely to respond excessively than people that did not think it was necessary. And we see that inverse relationship when it comes to not at all. So people that answered, yes, I think exterior residential light is necessary, way more said that it was not at all disruptive than people that said, no, I do not think it's necessary. Far less people said that it was not disruptive at all. And we can see this pattern goes through every single category of Allen. This is shown. And we also know that from the data that the most commonly responded level of disruption was moderately, except for exterior residential, which we thought was an interesting observation. So we can see how many people believe that it is only slightly disrupting, as opposed to moderately. And this could be for a very wide range of reasons. However, we've speculated that it could be perhaps due to personal safety reasons. As Julie mentioned, a lot of people believe Allen to have a positive effect on personal safety as opposed to a negative effect. And so having lights around your personal home might be viewed differently as other sources just because of that personal safety aspect. Now Lisa will be talking about our second social science research question.
Thank you, Chloe. So our second question for social science was, is there support for reducing artificial light at night amongst residents and visitors on the Outer Banks? So to answer this question, we put something on our survey. Please indicate your level of agreement with the following statement. Artificial light at night in the Outer Banks should be reduced. As we can see, about 90% of respondents said that they either agree or strongly agree with this statement. When we broke this question down further, we also saw that the majority of both residents and visitors agreed and strongly agreed with this statement. To break this down even further, going back to Julie's slide about the question about the level of concern with Allen, we saw that those who answered agree and strongly agree to this statement also were concerned or very concerned with the amount of Allen in the Outer Banks. So from this, we can see that both residents and visitors strongly agree with this statement and agree that Allen should be reduced, as well as being concerned about Allen. To talk about more results, I'm going to hand it over to Drew.
Thank you so much, Elise. Now we want to talk a little bit more about just a question that we asked on the survey about the public's willingness to implement individual reduction methods at their place of residence. Some of these reduction methods include turning off outdoor lights, using blinds and curtains at night, using outdoor light shields, and installing dimmers on outdoor lights. We see that the most popular two options are turning off outdoor lights and using blinds and curtains at night. I think this is a logical finding since these are two of the more easy adjustments to make, considering most houses already have blinds or curtains, and turning off the lights only takes a flick of a switch. So the less supported methods of reduction were warmer tones for electronic devices and installing dimmers on outdoor lights. Some of the maybe more complicated ones to make these adjustments, and also ones that might require more investment. But across the board, we see that there is lots of support for reducing ALAN on an individual basis at places of residence. We wanted to find relationships between variables that might have influenced willingness to make these individual adjustments at places of residence. So we found a significant relationship between ALAN concern level and willingness to install dimmers on outdoor lights, use warmer tones on outdoor lights, and to change electronic devices to be giving off warmer light instead of the blue light. So this left graph is demonstrating the willingness, the people who said that they were willing to make these adjustments, and the right graph represents the people that were unwilling to make the adjustments. As you can see in the left graph with the people that are willing, many more people said very concerned, which is in blue, and concerned, which is in orange, than the people that were not willing. And on the side of people that were not willing to make the change, we see there are many more people that responded slightly concerned or not concerned at all. We also found a significant relationship between night sky appreciation, the frequency of that, and willingness to make these adjustments at their place of residence, with warm tones on outdoor lights, outdoor light shields, and warm tones for electronic devices being the methods that were affected by that. We see on the left side, once again, willingness, and on the right side, once again, unwillingness. Blue and orange represent often and always, and we see that these are much higher on, well, they're higher on the willingness chart than they are on the unwillingness chart. And for the people that were unwilling, we see that the more common a more common response was rarely and sometimes. We also asked about support for reduction on commercial and municipal levels using warm tone light bulbs, light shielding, motion sensors, and turning off outdoor lights. And across the board, over 75% for all of these reduction methods, there was support to do it at both a municipal and a commercial level. So now I'd like to welcome Laura to talk about the crossover between our natural science and social science.
Thank you, Drew. So for our third and final set of results, we specifically wanted to look at natural and social science variables together. So for the first two variables that we compared, we looked at satellite-based ALAN against one of the specific questions on the survey, which was asking what time residents turned off their exterior lights. So the way in which we did this was taking the satellite-based ALAN and averaging them together based on which town they fell into. So again, from south to north, and the time in which the residents turned off their lights is represented in the blue boxes, and the satellite-based ALAN is the orange line, and the average time that residential exterior lights are turned off is not directly related to ALAN levels along the Outer Banks coast. However, when looking at this, we did not ask about what time businesses or other properties around the area or towns turned off their lights. So while there isn't a direct relationship between these two, we are not certain as to what is causing the most effect to ALAN. And now Ella to talk about our second set of variables.
Thanks, Laura. So we also wanted to go back to that knowledge score component of our survey that Ashlyn talked about. So we took each knowledge score and divided them into their respective towns. And then we also took the radiance or level of ALAN and also divided that by town. So the blue columns is the scores for the knowledge test, and the orange line is the ALAN level. So as you can see, there is a little bit of a correlation here, but also if we look at the knowledge scores first, they really don't vary very much. The lowest one, which was in Kitty Hawk, is only 5.7, and the highest, which is in Kerala, is a 6.5. So that's not even a 1-point difference. However, it does look like where the knowledge scores slightly increase, the amount of ALAN largely decreases. And we do think that could be due to the policies in the area. For instance, in Duck, there are policies that are put up that do limit the amount of ALAN in the area. So, and now Abigail's going to come and talk to us about concern.
Yeah, so the last thing we wanted to look at was level of concern and how that compared to our average satellite-based ALAN from 2014 to 2022. So for the purpose of this graph, we took the percentage of respondents that indicated they were either concerned or very concerned about ALAN, and then we overlaid that with the average ALAN from 2014 to 2022, which is seen in the orange line. When we did this, we saw that some of our highest percentage of concerned respondents were in Duck and Kerala. Those were also the areas with some of the lowest average satellite-based ALAN. So one reason for this could be that respondents in this area are more aware of ALAN and are more keen on wanting to keep their levels low. So now I'm going to take us through some of our conclusions, beginning with natural science. One of the biggest takeaways from the natural science portion of this research is that the Outer Banks is losing darkness across the Outer Banks. The same sites that were the brightest in 2014, we saw to be our brightest sites in 2022. And then we saw that same trend with our darkest sites. Our darkest sites in 2014 were the darkest in 2022. We did see that we saw similar trends using on-the-ground and satellite-based methods of data collection, which would be good for future research. And then we saw that nests do not correlate significantly with light, but false crawls do correlate significantly. For the part where we did not see a correlation, Kenza talked to us about a few reasons why, one of which might just be that there's another factor that's overpowering our ability to see a correlation there. And now Nikki is going to talk to us about social science conclusions.
All right, so just to reiterate what we already discussed with our social science part, we found that both residents and visitors are very concerned about ALAN levels on the Outer Banks. We also found that respondents perceived ALAN to negatively affect all the options given, which included safety, it also included sea turtles, and the other ones that we already went over. Additionally, demographics also influenced those responses. Residents and visitors both supported reducing ALAN levels, and majority of respondents supported individual, commercial, and municipal reduction measures. Now I'm going to talk about just a few of the methods to reduce ALAN, which we have talked about just a little bit in this presentation already. So some ways that you can actually reduce your own ALAN at your home or at your business is to turn off your outdoor lights and use blinds or curtains at your home. Additionally, you can also use motion sensor lighting that only turns on when there is motion in the area. So that still can help with the safety aspect. And then you can also use outdoor lighting shields, which decreases the amount of sky glow that enters into the upward portion of the atmosphere. Now, Elise is going to talk about some future research.
Thank you, Nikki. So as far as recommendations for future research projects, we only had about 3 months and the size of our team to do all of this work, so future projects could encompass more of the North Carolina coast to involve other areas. You could also look at other organisms and how they're affected by ALAN. In this study, we only looked at sea turtles, but you could look at other organisms native to the coast. And then a community science project could even use the sky quality meters. They're relatively cheap and easy to use, and this could be a great way to look at the Outer Banks light levels across time in the future. Once again, we'd just like to acknowledge the following people who helped make this capstone project possible. And I'll hand it over to Lindsay.
Thank you all. If you'd like to please come up to the front, all of you, and we are going to request that anyone who has questions or wants to make comments to the students or give them any feedback, just wait till I reach you or Linda reaches you. Oh, okay. With just when I reach you, apparently, with the microphone, so that the people who are online can hear and everyone in the room can hear. So yeah. Questions? I would have been disappointed if you didn't have one.
Did any of you get very much surprised by some of the work you did? You made an assumption and it was absolutely wrong or really right? just as you were going through the work this summer?
I think a lot of the sea turtle data surprised us and how it's correlated with artificial light at night. We kind of assumed that maybe false crawls occurred more where there was more light because sea turtles would go on the beach and then get disrupted by the light and choose to turn around. But that's not really what we saw on our coast. So that surprised me.
I worked primarily on the social side of things, so even though I was also surprised by the turtle data when Kenza presented it to the rest of us, I was more looking at people's perceptions of Allen. And what really surprised me was how in the know people already seemed and how concerned about it they already were. We were going around passing out surveys, and everyone we passed out a survey to would go, "Ugh, I hate Allen. My neighbors always have their lights on." And it surprised me how often we got that response, for sure.
Okay, thank you. Does anyone else have? Okay, great.
Hi, y'all. I'd love to talk a little bit more about false crawls, or at least ask a question about it. So in your data, it looked like the false crawls correlated with the amount of light availability, in that up near Kerala, there were a lot of false crawls, and down near Oregon Inlet, there were a lot of false crawls, and those are both pretty dark areas. And of course, where the towns are, there is not so many false crawls, and that's a very lit up area. But are there also factors perhaps in how many nests are laid up in Kerala? Because it's a pretty northward place. I would think that if it's a little chillier, or of course it's the four-wheel drive zone up there, which means there's cars rolling around all over the place, that might discourage a sea turtle. Or also it might have to do with down near the Oregon Inlet, if there's a lot of nests being laid, is there just a higher ratio, like an average ratio overall of false crawls to total crawls on the beach, in that like there's like a constant ratio of how many false crawls there is based on false crawls plus actual nests laid. Is there an average across the Outer Banks, or is there something like very different?
We did see like more on average. Even when we like standardize it to the amount of nests that we're seeing in general, we still saw that there were more false crawls in the north and then in the south again. We don't, like, in general, there's not a lot of research that understands why turtles false crawl. And so we don't really understand all the variables that like play into why a turtle might false crawl. So yeah, in Corolla and in the north, maybe because of all the driving that's happening on the beach, maybe that's causing a lot of turtles to turn around. Maybe in areas where it's lit, turtles see the light from the ocean and choose not even to go on the land to false crawl in the first place. We just don't really fully understand why turtles false crawl in the first place. So I think this kind of trend that we're seeing, it might be not because of the light at all. There might be other factors playing into it that we just don't really understand yet.
Thanks for the question and for the answer, Kenza.
So thank you and congratulations to all of you. I had a question about the sea turtles as well. I know that some beaches record instances of sea turtle hatchling disorientation. Did you have any access to data like that? And if you did you know?
No, we didn't look at any of that data. We didn't have access to it, but there have been a bunch of studies that have shown that it definitely does disorient hatchlings that are going into the water, making their crawl into the ocean.
Thank you.
But we didn't look at that.
Thank you.
I just want to clarify one thing. We did have access, but we did not look at it. It was not part of the study. Any other questions in the room or any questions online? Okay. Oh, okay. I'll start with you.
Fantastic job, everyone. I'm really proud of y'all. I have a difficult question for you, though. Is there anything about this project that you wish you could have done differently if you had to do it again?
I think we all had a pretty good time. And thank you so much to Ms. J for giving us an amazing place to live, and everyone who lives in the guest house, because, yeah, y'all are good to be around.
One thing about this project that was like down to the wire was our survey responses, maybe starting earlier or finding more ways. As we presented in our study, we did hit our target goal, but we had to be on the ground surveying all the time. If there was more online forms of getting the survey out there, I think that would have been helpful. But we did get a lot of responses as it was.
Okay, one thing is that when you're making a survey, you're not sure how it's going to come across to people until you have 500 responses back, and like 50 of them are saying they don't even live in the Outer Banks, and you're like, okay, I don't know what to do with this now because you're saying you're from Canada, and that's nowhere close to the Outer Banks. So yeah, I think that's something that comes with time, is knowing how different questions are going to come across to people, and they have to be very specific. And yeah, that was one of our major problems, is that we asked people where they were living or staying, and someone put Canada, and several other people put places that were not in the Outer Banks, and we couldn't use that data. So it's just one of those things where you're like, I wish I could change that, but yeah.
So all of you have different internships and different programs that you interned with. How does the information that you gathered get back to municipalities and affecting change within what your research is finding back to where we can affect a change?
I mean, I can start. I don't know if anyone else wants to, but I interned with the town of Duck. So I think I was unique in actually being able to present some of the research I did in my internship to the town council there. And that research that I did is still going to be ongoing, I believe. So it's my hope that it's still going to make some sort of change in the town of Duck, and I think everyone else, to some extent, feels the same way.
I also did some research during the semester. I interned with the North Carolina Coastal Federation, which is a private organization, but I did work doing research about how the state has received funding for oyster sanctuaries. So I think smaller organizations play a huge role in getting this sort of research out into not only smaller like municipal governments, but also up to the federal and state levels. Working with, not that we will be doing this, but ideally I think working with private research or lobbying interest groups would be a really great way to kind of get more exposure. I know that the North Carolina Aquarium is interested in the research that we've done this semester, and I would like to hope that once the aquarium gets a hold of our information, maybe some other organizations will also gain interest as well.
Another answer to your question, a big way we try to make our research have an impact is our audience here tonight. We invited all of our internship mentors to be here, as well as the entire community. It was on our survey that we passed out, and we're hoping you come here, you learn something new, and you take that away with you and let it influence your decisions.
All right, I've got a question from online. Melody would like to know, after doing this research, would any of you find yourself doing research again in the future? And I will also add to that, did any research that you may have done for your internship pique that interest as well?
So I specifically did not have a research project with my internship, but I have done a research project before coming here and also this, and I will say that I do find research to be a very interesting field, and I love to just get back the data after months of working with it and then be able to just mess around with it and find graphs and see the correlations and everything like that. So research is an option that's still out there, so yeah.
I would like to say I think it's really interesting. My parents do research, so I've been around it since as long as I can remember. I think it's a really awesome way to advance the way that we live. Nothing would really, there's so much progress that we have made due to research, and although it looks like a bunch of numbers and graphs at first glance, I think it's the first step to a lot of really great progress that we've made as a species, and I think I would love to go into research personally as a field of work. I think that'd be an incredible thing to do with my life.
Okay, thank you, Melanie, and students for answering. Jane?
Hey guys, congrats, really great presentation that you guys delivered tonight. Thank you so much for sharing with us. One question that I had was about the human dimensional analyses that you guys performed. Was there any standardization that you guys had for the sites where you were surveying, and or if there was no kind of standardization or like criteria for where you went to obtain this information? How do you think that where you were able to survey and the participants that you subsequently got influenced your data, if at all?
Yeah, I think it's a great question. I think we could see a difference in some of our data from places like Kerala or also down closer to Oregon Inlet. Maybe there would be a different response as to like what people see as disruptive and what people see as necessary, just because, you know, maybe they chose to live in an area like that with less light because they see it as more disruptive or they see it as more necessary. So I think these places where our survey went out online, specifically Duck and Kerala, like up north where there's not as much development as maybe like a Kitty Hawk or a Kill Devil Hills, I think that definitely could have had some type of effect.
So when we were distributing our survey, we really did try to go to a lot of different places. I won't say that there was anywhere like specific that we were like, oh yeah, we need to go there. We did try to go to grocery stores. Those did not often let us survey there. I will say like we went to a lot of coffee shops which also might have impacted our demographics. We went to the farmer's market. So we tried to get a lot of different places with a lot of different age demographics in there as well. We weren't really targeting like any specific age like bracket. We just kind of like went everywhere that we were able to. But like we mentioned, we were able to do the electronic survey in Nags Head and Duck, and we do wish that we had gotten more responses. We sent that out to a lot more of the towns, but we just didn't get responses from them. And we think that we got a lot of our surveys respondents from those electronic means, because I found it interesting that when I was actually intercepting people, a lot of them were visitors. So what I expected was that we were going to get majority of our respondents visitors, but it turns out that a lot of our respondents were those year-round residents, and I suspect that that was because they answered online rather than when we were actually distributing it in person. So that was just an interesting finding.
I also just wanted to add on, so as Nikki mentioned, the large majority of our respondents were residents. We didn't really get to start surveying until the peak tourist season was over. I think if we were to have been able to survey before Labor Day weekend, I feel not only would we have more visitors, but we might have seen a difference in the data due to the skewed population.
Okay, okay.
Good job, y'all. I just wanted to ask, I noticed at the end when you were doing the comparisons with your natural science questions and your social science questions, those data sets and those certain variables, that you used the satellite data to compare instead of your data that you collected with the handheld thingy, I forget what it's called. Can you speak to why you made that decision? Was it more of just the satellite data is a larger data set and it's more robust, or was there another reason that caused you to choose that?
Yeah, I think the main reason was because we had that data for over 9 years and like every month, whereas the sky quality meter, the on-the-ground measurements, we were only able to go out during new moons, and that was only 3 times a semester. So we didn't want to use that data to be like, this is this correlation, that correlation, because it doesn't show the same amount of correlation as satellite data would. It's over a larger period of time.
Okay, I saw a couple more hands up. Okay, I'm going to go over to this side of the room.
Great job, everybody. And looking back over the entire experience, what's the number one thing you think you learned? And second, given the opportunity to do it again, would you, recognizing that yes and no are both acceptable answers?
I think the biggest thing that I personally learned was like how to work with a group. I've worked with like groups obviously in school before, but not one of this size for this long of a period of time. There was just a lot of things that we had to discuss as a group, which it's important because you get to hear a lot of different opinions, but it also makes it more difficult when you're trying to make decisions. So there was a lot of discussions. We had to discuss where we wanted to sample on the beaches, how often we wanted to sample on the beaches, who was going to work with what data set, who was going to survey where, when. There's so many things that went into this. So I think that was probably the biggest thing, and also the data analysis as well. I haven't done as much data analysis in my time, my college career, or any education really so far. So I think that getting to work with that data was like definitely new for me, but I think it was a good skill to learn. And would I do this again? I don't know. I really don't. It was a lot to say the least. And also interception is not my forte.
Yeah, I think I had a similar experience. It definitely is difficult working with a group of 12, but it was also really rewarding. And I think in the end, we all worked really well together, and it was a really fun experience, and I would definitely do it again.
I would definitely also do it again. It was a long, hard road, but it was very rewarding. I think everyone can speak for this, but I have come away understanding Excel on a level that I never thought I would. I thought I was familiar with Excel, and then we've had to do, I can't even tell you how many calculations and all sorts of pivot tables and all kinds of things on Excel, significance tests. So that will be going on my LinkedIn profile. But yes, lots of Excel. And I'm grateful. That's a great skill to have, so I'm grateful for that.
Great. Well, thank you. Everyone else is going to pass on that one, huh? Thanks. All right.
Going back to the sea turtles and other organisms, animal life, that type. Is there some follow-up research that you feel should be done or you would like to see done on that? Because it seems as though the data is still not necessarily incomplete from what you have, but there's still some outstanding questions about it.
Yeah, absolutely. I think that continuing to monitor the trends and looking at turtle nesting and turtle false crawls and how that's changing as we're continuing to lose darkness is really important. So I think that continuing our research and continuing research also with other organisms along the coast and seeing how artificial light might impact them as well is really important stuff to do.
Okay, thank you. Oh, we have one more online. Okay. This will probably be our last question so that folks can go get some snacks and drinks and look at posters.
All right, so the last online question is from Marcel. They would like to know, well, yes. So you all had the opportunity to ask a lot of other people about their knowledge of Alan and their opinions, but they would like to know what has changed for you all as individuals, both before and after this study.
I can only speak for myself, but I think a lot of us didn't really know that much about Alan, like before doing this project and coming here. And I mean, even just like when we're like walking around at night, we're like point out things to each other all the time. And I just feel like it's really like changed how we view like the environment that we're in and like looking at how everything affects each other. Like Alan is just like one example of that. I don't know if anybody.
Yeah, I think it's like when you think of pollution, we don't necessarily think of light pollution always. And so reading all the research we did before this, all the previous research that's been done, and showing like just how many organisms Alan is impacting really opened my eyes to its potential impacts.
Yeah, to agree with Sarah and Kenza, I personally had never really thought about Alan before. So learning about it was like a whole new world, and it has a ton of negative impacts on the environment, and I didn't realize what a big player it was in that category. We didn't go over it as much in our presentation here tonight, but in our paper, we delve deeper into the impacts it has on organisms and on humans as well. And it's just crazy how much it affects everything. And then I also didn't realize how easy it is to make adjustments to fix its negative effects. One thing that stood out to me was just on like a street lamp. Right now, its light is facing everywhere. It's going everywhere. But if you just put like a little structure around it, the light points downwards, and you can still see what's in front of you, and you can still feel safe. But now it's not blocking out the night sky nearly as much. And so that was interesting.
Great. Well, thank you so much. And also, thank you, Julie, for mentioning that there's a report that accompanies this presentation. I forgot to say that. So the report will be available, like I said, if you search for us online, it will be available online probably next Monday at the UNC Institute for the Environment website. Or you can always find Linda or I here at the Coastal Studies Institute and email us, and we can email the report to you if you'd like to learn more about the details of what the students did. And I guess that's it. Thank you again so much for coming. Please stick around for some food. The food is on the 3rd floor. There are drinks on the 2nd floor. There are posters on both floors. And you can talk with the students a bit more and mingle. And thank you, students. You did an awesome job.